Hi. I'm gonna jump out of this tree. Oh my goodness, is that an intro? I don't even know if I'm gonna make an intro. I might have just done that beginning section. And it might just cut right into this. I don't know if I'm gonna make an intro. So, if there is, I'm just gonna cut this part out. Hi. I'm back. You can't escape from me. I know. Such a blessing for you. So, I'm back in a tree. And let's just get into this. Also, yes, it is raining. But Mama didn't raise no quitter. If it suddenly cuts, it's because it started raining really hard and I don't want to get soaked. And also I have stuff that I can't let get soaked. But now, get into the video. So you might be wondering, well, what is the video? Here, let me set you down here. Oh, I don't like that angle. Hi. Actually, no, this is cute. Okay. So I have this. You might be wondering, well, Ren, what is this? And to that I say, I don't know. Don't judge me. I tried my best, but I genuinely have no clue what's in here. I'm not gonna lie. You can't see it, but the amount of times that I have to, do so much work just to find a place where I can put my recording device, so that way it doesn't fall out of this tree. I have put more work into this than I have, any of my schoolwork. Speaking of schoolwork, ta-da! You might be wondering, well, what kind of schoolwork is this? It's not. It's not my schoolwork. It's actually my teacher's. And basically, we're going to be going through my college level math notes that I got from my math teacher 2 years ago, which I took a solid year to read through not because it was hard, but because I couldn't read it. And by couldn't read it, I mean it was a combination of I didn't understand what was happening, also coupled with I'm tired, I don't want to do anything. So, I dusted them off after spending a full year reading them, and then a year of not even thinking about them. I quickly reread them, and now we're going to do an unhinged recap of college math notes. This is probably the moment where I should mention these may or may not be illegal. Freaking try me, Zeus. This mother trucker. I have to keep censoring myself. This man's is making it rain. It's actually raining. I'm just in a tree, so I'm not feeling it, but yeah, I may have illegal notes, and I think Zeus is trying to kill me for it. Anyways, let's go! So, let's just get into it. Basically, here's how this is going to work. I am going to give a short, as short as I can, summary of every single chapter. It's split up into, the different classes. There's a separate page for, each class. So each chapter, each page, I'm going to be giving a quick summary of everything that is important on that page. Starting with number 1. Basically, number 1 is just an intro to the class. He's basically just so when I say he, I'm talking about the professor, the lecturer giving this class, who taught my math teacher, so that's a fun fact. Basically, he's talking what is the history and philosophy of mathematics? What does that mean? What does philosophy of mathematics mean? If you think that you're just gonna memorize a bunch of dates and then learn how stuff came to be, you're wrong. You're wrong. You're actually wrong. Yeah, basically just what is philosophy and history and mathematics? How does it work? What are you gonna be covering? All the fun stuff. Basically, this also includes the two different like arguments between mathematicians. Number one, there's the constructivists and then the non-constructivists, and then there's the intuitionists and there's the formalists. Non-constructivists and constructivists don't like each other. They have differing beliefs about mathematics and what it is. Same for the intuitionists and formalists. It's just people in math arguing because they care about stupid numbers. I digress. I'm not a mathematician, so don't ask me which one I am, because I don't care about your petty squabbles. So moving on, basically it starts in like the old days of like way too long ago. And like, ooh, what originally is math? Basically, Babylonians, Egyptians, the Greeks, the Chinese, Indians, they began math. So like, counting. I wish I could have been there, because that's all the math I want to do, ever. But moving on, basically the only thing I gained from this chapter was the Egyptian doubling method, which I used on a math test. Yeah, that is like my greatest achievement in life so far. I used the Egyptian doubling method for multiplication on a math test, which is harder than just regular multiplication. So why did I do it? The world may never know. Oh yeah, unit fractions are also introduced. That gets important later, but we don't care. And then estimation for square roots, which these are just like basic maths. I understood this. Next, Pythagoras. Pythagoras did some stuff. Whether he actually did it, we don't know if he was real. And we don't know if he actually discovered anything. He might have just copied stuff. But he had a cult. Let's talk about this. No, because when I tell you that my one goal in life is to be like Pythagoras, I mean it. Like, let me tell you. This man... I need to set this down. Set the notes down. No, we're full ranting here. This man started a cult. What more do you need? Nothing else. But let's talk about this. He started a cult. They were wild. Murder, killing people because they just did stuff that they didn't like mathematically. Icon. Goals. I think I should start a math cult. No more context is needed. Also, Pythagoras and his death. Basically, he was being chased. Some people wanted him dead. He had the option to either A, run through a bean field, or B, give himself up to the people who were chasing him and planning on killing him. He chose to die rather than the bean field. Let's go. Oh yeah. That is my one goal in life. Is it disappointing? Maybe. But I do think that, in the sense that that was iconic, and I really think that is something we should all strive to be. A mathematical cult leader who may or may not have existed, who got killed for beans. Thank you for coming to my TED Talk. Mathematical cult rant over. Let's move on. So now we are on chapter 4. Basically chapter 3, Pythagoras, the Pythagorean theorem, his cult, random stuff that they did, random stuff that they didn't like. They didn't really like square root 2. Let's talk about that. I don't either, so. Hear me out, Pythagoras. Call me. Call me. If you need a predecessor to your cult, you've got an applicant right here, ready. Number 4, Euclid. Wait. No, I'm stupid. Euclid, more like I'm stupid. This is not Euclid yet. Sorry, I read the chapter title, which is Classical Greek Geometry. Can you blame me? No, because I'd be willing to bet half the people watching this or listening to this, if there are any, don't know a single thing that I'm talking about. Because neither did I. So this one is like the stuff that existed like before Euclided. Yeah. Platonic solids. Me. Opposite angles of intersections are equal. The base angles of an isosceles triangle are equal. Area of a circle is bisected by the diameter. Triangles are congruent. Like, yeah, no, that kind of stuff. And then also just like polygons. Polygons and some like 3D shapes. And like that's really all they did. Oh, and then also how to calculate an area by breaking it up into triangles. Next chapter is Euclid. So Euclid, basically, I'm going to give you a quick summary. Euclid, he creates the major 5 axioms of geometry. 2 points define a line. A line segment can be extended indefinitely. All right angles are equal. Every circle is determined by its center and radius. If a transversal cuts 2 lines, basically the side where the angles added together equals less than 180 is the side where they meet. And then it goes on to like, ooh, the more defined Euclidean geometry axioms we have today, we don't care. Conic sections, that's really it, and then proportions and ratios. Number 6, number theory. Primes. Prime numbers. That is all number theory has ever been, apparently. I didn't know that. No, because, like, literally, this entire chapter is just dedicated to, like, primes. How to find a prime. The basics of, like, what they knew about primes. And that's it. I don't really have much else to say. It was just, like, primes. Which is cool, but it does not affect me. Moving on. Lecture 7. This one's a fun one. We start getting into weird stuff. Basically, Chapter 7, the title is What is Infinity? Beautiful intro. Part 1. Let me put that in there. It's a part 1. Like, no, literally, it's a part 1. No, see, like, it's literally part 1. Yeah, so basically, it's just like, ooh, what is infinity? And then we meet this one guy. Where is he? Zeno. Zeno just creates multiple paradoxes that say, hey, infinity can't be real. Infinitely divisible things, non-existent, because bad stuff happens. Basically, a lot of paradoxes and confusion. Infinity, don't know her. That's for losers. And that's honestly, like, all of Zeno's paradox. Oh, and then also approximating pi, and they find the area for a couple more, like, 3D shapes. That's really all that happens in this chapter. Let me talk about my favorite paradox, though. It's the arrow flying. If you shoot an arrow, if there are infinitely divisible units of time, you can divide time so small to the point where in that one unit of time that you have that is infinitely small, the arrow won't be moving. Basically, arrows don't move. And then if you add up, like, no movement infinitely many times, like, 0, like, times infinity is still 0. So, like, therefore the arrow is not flying despite the fact that it is. So infinity is non-existent. Number 8 is about Archimedes. The only thing I get out of this chapter is how Archimedes died. If I don't die like Archimedes, I'm coming back to life, and you all are required to try and kill me like Archimedes. Thank you. Basically, Archimedes dies because his city is literally under attack, but he doesn't care. He's just sitting in the corner, drawing shapes in the sand, doing math. Basically what happens is a soldier walks up to him, blocks the sun so that way Archimedes can't see the shapes he's drawing in the sand. So he cusses out the soldier, who then stabs him and kills him. I don't have anything else to say. Thank you. That is how I want to die. It's just about Archimedes using, like, triangles to estimate the area of a shape. And then also there's a formula here that's actually, it's one of my favorite. It's Heron's formula. If I remember, wait, I'm trying to do this from memory. You better not quote me on this if I do it wrong. The square root of s minus a times s minus b times s minus c times s, where s is equal to a plus b plus c, all divided by 2, where a, b, and c are the side lengths of a triangle, is equal to the area of any triangle. Yeah, I'm correct. Okay. You are all losers. I'm always correct. Moving on, we're on chapter 9. There's 38 chapters. I might have to split this up. Basically, chapter 9 is Diophantus. If you want his name, I guess I could write it somewhere. He lives, he does math, and then he dies, but there's a riddle on his tomb. Calculate how long he lived. I got it wrong. I misread it, and then I did something wrong with basic arithmetic. You can't judge me. I made simple mistakes. Okay, it's not my fault that I'm stupid and illiterate. This man just standardizes notation, by the way. That's, like, really his main thing. Up until this time, it's important to remember that, like, most math was being done entirely in word problems. And it still is done that way for a while, because math was seen as, like, a representation of truth in the real world. So they would use real-world scenarios to describe math. Oh, yeah, and then Hypatia, I don't know, but we stand her. She was a girl boss. She also got dragged behind a chariot, cut up with clams, dismembered, and then burned for being a woman. Next, we move over, Chinese and Indian mathematics, where they were actually doing stuff. Linear systems of equations. Fun. Chinese square root algorithms, you know, finding the square roots of stuff. I'm not gonna lie, I don't remember too much of this. Oh, and then Yang's triangle. Pascal's triangle. That was such a struggle for me to remember that. But Young's triangle existed first. And then the cattle problem of Archimedes. The most complicated cattle problem in existence. No one should have this many cows. At that point, just make me 1,000,000 hamburgers. Is that disrespectful to Hinduism? I'm sorry. Go ahead and shoot me. Actually, no, you can't shoot me. Gotta remember to die like Archimedes, baby. Chapter 11 is all about the math of, like, Islam. So where did the word algebra come from? Your mom. Okay, you can go ahead and shoot me, actually. Perfect numbers and amicable numbers. 6 and then 28 being like the two smallest perfect numbers. Love those numbers, by the way. I always love those numbers. And now I have a good reason too, so leave me alone about it. They're perfect numbers. Some stuff for like calculating triangles and stuff. And then we get to medieval Europe, which is chapter 12. Fibonacci exists and we stand. We love Fibonacci numbers, which was meant to represent the growth of like a population. No, we get back to unit fractions. Remember how I mentioned those in Egyptian mathematics? You might have forgotten. I rant a lot. Here, let's make it fun and interesting. See? Angle change. Look at me go. Look at this production value. I gotta move so I don't fall out of this tree. Or I could. That would also be a sleigh. So unit fractions, basically what it is every single fraction, as long as it is rational, can be described as a sum of smaller unit fractions. And then there's a proof for it that they proved in medieval Europe. And that's slay. You can go ahead and shoot me. I'm gonna keep saying that. I think that's a great idea. Quadratic and cubic equations. Here's what happens. People can't find the solution to the general cubic. So there's Cardan, and he's a fraud. We hate him. I don't have much else to say. Basically, it's just a bunch of messy stuff where like, ooh, no, I solved the quadratic equation. No, I solved the general cubic. And like, shut up. And then you just prove the general cubic equation solution. Well, they proved it. I'm just reading the notes of them already proving it. Thank you, my math teacher. Thank you. He's not going to see this. If he does see this, well, he's going to go missing. So, you know, click away now. You know who you are. So next, chapter 14. It's about the quartic equation. It's blank. No, like, I mean it. It's blank. I was going to solve it. I literally was like, oh, I'll solve it. I'll do this math. No, you are not. You are stupid and illiterate. 15 is solved. You probably saw a little bit of that in the last clip. So, this one's about the cubic equation, and basically, so the cubic equation was solved. The issue was, though, a bunch of people wanted to claim their claim to fame, be like, ooh, I solved the general cubic equation. Look at me go. And so there was a bunch of drama, and there was a bunch of like, oh, I did it. Oh, actually, you didn't do it. Someone else gave it to you. Or like, and like mathematicians competing because they want prestige and fame and money, which like, me too. But I would not sacrifice my life to math for that. Just a bunch of really stupid drama because they just wanted to be the person who's like famous for solving the cubic equation. Slay. Boo. See, I scared you with these angle changes, girl. I'm about to keep it interesting. I'm a professional. No, I'm not. I'm stupid. There's a freaking branch right here, and it's messing with me. I'm just gonna suffer. We'll figure it out. Moving on. Modern mathematics starts to exist. So, trigonometry. Basically, so we've just established mathematicians are dramatic. Chapter 16. Trig. Oh my goodness, trigonometry. How are we all feeling? No, like literally trigonometry. But it's for trebuchets. Let's go. Oh, and time. But you know. Losers. Oh, and then like also just like proving the cubic equation and stuff. The development of logarithms, how they all worked. There's Kepler, Galileo, and Copernicus. Basically how astronomy and math got mixed together. More about logs, and that's about it. Chapter 18. We're getting there. We only have 20 more after this. I think I'm going to break this up into 19 and 19. Genuinely just because I think it's going to take that long. So second to last one. This one and then 19, and then we'll cut it. Basically, Descartes, Cartesian planes. So this one, more notation, where like stuff is being changed to like actual notation. Woohoo! Standardization of math. I love that. Now, let's not get crazy here. But the rule of signs is so cool. Descartes' rule of signs. Favorite thing in the world. basically in a polynomial, it's like the number of it's the number of changes between consecutive coefficients, like between positive and negative, is equal to the number of negative real roots. Or it's either that number or that number minus a multiple of 2. So do keep that, or minus a multiple of 2 in mind. But I love that. That is the coolest rule I've ever heard. Didn't know before this. So yeah, go read some college math notes. They're great. I swear, they're so great. Like, I swear I am so sane. I swear I am sane. You don't have to worry about my mental health. I am sane. You can trust me. This is not a brainwashing. This is not a cult. I would never start a cult about math. Anyways, you better watch out. Chapter 19, last chapter before I finish this, because I do not want to have to spend hours editing. I'm going to have to. I'm just going to break it up into 2 parts. Basically, this is going to be the last one. And I think it's fitting. It's pre-calculus, calculus. It's pre-calc. Someone and Newton and other people created calculus. This is the precursor. Basically, things like Gabriel's trumpet are starting to be introduced. It's a finite volume, but infinite surface area, which is like slay. Also, the soup bowl paradox, love that. Mathematicians are so uncreative, as I have learned. Like, after reading through this, they are the most uncreative people. So yeah, soup bowl paradox and Gabriel's trumpet, precursors to calculus. And then also the beginning of finding area under a curve, differentiation, derivatives and integrals, and all that fun stuff. Yeah, so that's basically pre-calc, at least from this perspective. Pre-calculus, calculus. And that's chapter 19, so that's halfway there. I'm so tired. I'm really, really tired. But I'm halfway there. Hopefully, I will continue to do this. Maybe. If I don't die, or if I don't start a math cult. Who knows? Maybe I start a math cult. That's the next video. Cut out on this. Math cult. Yeah, I don't really have much else to follow that. Math cult. That's how we're going to end this video. Math cult. Math cult. Math cult. Math cult. Just kidding. You thought? You thought. Right now I'm going to go in before the storm actually starts and before I actually get drenched. Along with my math notes. I have to keep these safe. I have to keep my maybe illegal math notes safe. We'll also get into that in the next video. So, maybe stay tuned. Maybe subscribe. You could like, because this took a lot of work. And I think it probably, maybe, really isn't funny. Anyways, you can enjoy the rest of your day now. Just know, the math cult will be haunting you. Bye!